Welcome to The Explainer. I am incredibly pumped to have you here today because we're looking at something just absolutely mind-blowing. We are going to completely deconstruct a highly specific, super dense cinematic film concept. Basically, the source material we're looking at outlines this bold vision for a 90-second, ultra-realistic miniature construction film. But it's not just some random building. It covers the complete construction of London's iconic Tower Bridge, spanning the actual historical years of 1886 to 1894. We are talking about condensing 8 years of monumental Victorian engineering down into a minute and a half of pure dramatic storytelling and breathtaking visual detail. It's like a giant historical puzzle brought to life in a micro-digital world.
Okay, let's dive into this. Here is our timeline for the build. First, the miniature cinematic vision. 2. Excavating deep river foundations. 3. Forging granite and steel. 4. Installing the giant bascules. 5. Victorian hydraulic engineering. And finally, sunset on Tower Bridge.
Section 1. The miniature cinematic vision. Right off the bat, we need to lay the conceptual groundwork for exactly how this historical documentary is meant to look. Keep in mind, this is completely devoid of any modern equipment, text overlays, or watermarks. To pull off this ultra-realistic vibe, the vision relies heavily on macro cinematography. Now, if you're not familiar, that's basically the art of filming extreme close-ups, making tiny realistic miniature workers and materials appear larger than life. It is literally the visual engine of the entire film. By combining these extreme close-ups with stunning 8K photorealism and a very shallow depth of field, you get this completely immersive world. And that shallow focus is absolutely crucial, because it naturally draws our eye right to those hyper-detailed micro-elements. You know, the realistic dust kicking up from the stone, water splashing from the Thames, and thick smoke puffing out of the steam engines.
And that deep immersion starts immediately. The opening scene completely sets the stage with an aerial sunrise right over the River Thames. The source specifically highlights the use of natural Victorian lighting to nail that authentic 19th century atmosphere from the very first frame. We see hundreds of tiny Victorian engineers and construction workers all showing up in meticulously detailed period clothing. This isn't just a technical diagram, right? It feels like a lived-in, bustling miniature metropolis waking up for a truly massive undertaking.
Section 2. Excavating deep river foundations.
So, moving down from the sky to the muddy riverbanks, we see surveyors measuring with chains and tripods, which kicks off the incredibly intense subaquatic engineering phase. Now, what's really interesting about this step is how they conquer the river. These miniature workers have to execute a brutal 4-step process. First, they actually build massive cofferdams directly in the flowing river, just to carve out a dry workspace. Second, they pump all that trapped water out. Third, they excavate deep down into the riverbed to establish the foundations. And fourth, they pour massive amounts of concrete to support the towers. It's this constant, heavy battle against the water, beautifully told through realistic miniature physics.
Section 3. Forging granite and steel.
Once those foundations are finally set, we enter the heavy construction phase. This is where the sheer mass of the bridge starts taking shape above the waterline. And the logistics of moving all this stuff are central to maintaining that 19th century atmosphere. We're talking heavy materials, like massive steel beams, timber, thousands of rivets, the equipment itself, and enormous granite blocks. Just to ground this in reality for a second, the actual bridge required over 31,000 tons of stone. All of this is transported by horse-drawn wagons. The historical accuracy is front and center here. Once they arrive on site, these towering, steam-powered cranes take over, unloading these massive payloads so the masons can carefully place every single stone as the granite towers slowly rise up.
At this point, the visual pacing really shifts. It becomes incredibly dynamic and sensory. Sparks literally fly as blacksmiths forge metal parts. You can almost feel the heat and hear the immersive construction sounds as steelworkers climb up these wooden scaffolds. They're connecting giant iron beams using incredibly hot rivets and steam-powered riveting machines. That shallow depth of field we talked about earlier, it focuses right in on those flying sparks, capturing the raw, dangerous reality of Victorian industrial labor, all in miniature.
And all of this happens as a full day unfolds over our 90-second narrative. We start at sunrise when the workers arrive. By midday, those mighty granite towers are already rising up. By the afternoon, the bridge framework is gradually stretching all the way across the River Thames. And what adds just a brilliant layer of realism here is that throughout this entire progression, ships are continuing to pass beneath the construction. The river doesn't just stop for the bridge, it keeps moving, pushing us closer to that glowing sunset finale.
Section 4. Installing the giant bascules.
Okay, so the towers are up, the framework is reaching across, and now we hit the critical turning point of the entire engineering project. But real quick, we need to make sure we know exactly what it is they're installing. Bascule leaves are the giant, movable sections of the bridge framework that physically lift up to allow large ships to pass through. This is without a doubt the defining mechanical feature of Tower Bridge. In our miniature film, the tiny engineers have to use enormous steam cranes just to maneuver these colossal metal leaves into position. It's this epic feat of heavy lifting that essentially bridges the gap between static architecture and a functioning, moving machine.
Section 5. Victorian Hydraulic Engineering. From there, the camera sweeps us inside the bridge itself, and the focus dramatically shifts from those massive steam cranes outside to the intricate machinery inside, because obviously, those giant basket leaves don't just move by magic. So the crucial point is that the workers are rapidly assembling this incredibly complex network of internal components: Victorian hydraulic engines, an endless array of gears, massive pistons, driving shafts, and super heavy counterweights. It's like this beautifully choreographed mechanical ballet, transferring immense power to allow the bridge to split and rise. The source material captures this internal work so vividly. It says close-up macro shots show grease-covered hands tightening bolts, measuring gears, and testing machinery. Remember how the prompt asked for immersive construction ASMR? Well, here it is. You can practically smell the grease, hear the heavy clinking of the wrenches, and feel the tactile, macro-level effort of these tiny, hyper-realistic workers fine-tuning this gigantic 19th century mechanical puzzle. All of that meticulous, grueling internal work leads us directly to the triumphant climax of the 90-second film, the first mechanical test. The gears turn, and the giant bascule slowly but successfully rise. A large Victorian steamship safely passes beneath the newly opened bridge. And in just a fantastic, emotional, cinematic touch, the tiny miniature workers break out in cheers, celebrating their total engineering marvel. The bridge actually works!
Section 6. Sunset on Tower Bridge. We're nearing the end of our journey now, guiding us into the final scenes where the brute force construction gracefully transitions into delicate finishing craftsmanship. We get to see a really brilliant contrast in the timeline of the build here. We've spent most of our time down in the grit of industrial heavy lifting, the deep excavations in the riverbed, the hot-flying rivets, the massive cofferdams. But these final shots pivot beautifully to decorative craftsmanship. The camera catches painters applying protective coatings and craftsmen meticulously installing street lamps, intricate decorative stonework, and precise railings. It highlights this incredible micro-to-macro arc, proving that this bridge is just as much a pristine work of art as it is a feat of raw engineering.
And this brilliantly illustrates our final visual payoff. The completed Tower Bridge standing proudly at sunset. There is so much kinetic energy in this final tableau. Horse carriages are now actively crossing the road above, while ships continue to sail freely on the river below. All of this is captured in a totally smooth, dramatic, cinematic drone orbit around the finished bridge. The ultra-realistic physics and authentic Victorian architecture look absolutely stunning as the whole city of London glows beautifully under that warm evening light.
Which brings us to a final thought I want to leave you with today. By taking an 8-year, colossal endeavor like the building of Tower Bridge and compressing it into a 90-second, hyper-detailed miniature world, we actually get to see the forest and the trees all at once. We see the sweat, the grease, the gears, and the absolute grandeur in one seamless breath. So what does this all mean? Does viewing history through this kind of miniature, ultra-realistic lens change how we connect with the engineering marvels of our past? I think it certainly makes the monumental feel deeply personal and breathtakingly accessible. Thank you so much for joining me on this explainer. I hope this deep dive leaves you with a profound new appreciation for both Victorian engineering and modern cinematic vision. Keep exploring, and I'll see you next time.